Most business data describes dollar amounts in the hundreds, thousands, or hundreds of thousands. A lot of scientific data, particularly in the fields of biology and astronomy, describe much larger quantities. For example, you might have celestial bodies that are millions or billions of miles away, and you can see those distances in light years expressed here using exponents. If you do need to work with data that contains extremely large values, then it makes sense to use logarithmic scales, and I will show you how to do that in a chart in Excel in this movie. My sample file is 0203 logarithmic scale, and you can find that in the Chapter 2 folder of the exercise files collection. This workbook contains distance data for stars and galaxies, so the values are extremely large. But before I get into how to change the chart and what it's actually showing, I want to review exponents and logarithms. An exponent is used to multiply a number by itself. For example, in cell A13, you can see that I have text for the formula 2 caret 3, and the caret is used to indicate an exponent. And if I go into cell B13, type an equal sign, and then 2 caret 3, and enter, I get the value of 8. So that means that 2 multiplied by itself 3 times, 2 times 2 times 2, gives you 8. The inverse of that operation is to find the logarithm. So if I want to find the logarithm of 8 base 2, Excel will calculate the number of times you need to multiply 2 by itself to get the number 8. So in cell B14, I'll type equal log and then 8 comma 2 and enter, and you see I get 3. And that's because 2 raised to the third power is 8. Now let's take a look at the data that we have in column B above the calculations I just did, and I'll click in cell B6. That value is displayed in scientific notation, and you can see it's 3.5 e to the plus 1. So in other words, it is 3.5 times 10 to the first power, and that's in light years. And if you look on the formula bar, you can see the value of 35. So that means that you have 3.5 times 10, which equals 35. So it's a relatively close star or galaxy. The next value in cell B7 is 9,760, and that's 9.76 times 10 to the third. And that continues down to the last value in cell B11, which is 90,210,000 light years away. So that is a relatively distant object. If you look at how that data is displayed in the chart, you can see that the vertical axis starts at 0, and it goes all the way up to 1 times 10 to the 8th, which is large enough to contain the largest value in our data set. And you can see what that does to the scale. So our first, second, third, and fourth values are barely off of the baseline at 0 compared to our largest value. You can see 4 maybe peaking up just a little bit, and 5, you can see that the center of the dot is off of 0, but they are incredibly small compared to our largest value. So that means you might want to change the scale to logarithms. To do that, I will right-click the vertical axis and then click Format Axis. The Format Axis task pane appears, and on the right, you can see under Display Units that you can change the scale. So I can go from a linear scale, which is just counting 1, 2, 3, 4, 5, and change it to a logarithmic scale. So I will check that box, and I'll leave the base as 10, because that's the way that the data was created. And you can see that now the chart is much more readable. You have to know beforehand that you are reading a chart that has data shown based on a logarithmic scale. But for someone who works with scientific data, that's not a hard thing to do. It's something that you will do all the time. So if you need to represent data with extremely large values, such as for astronomy, biology, or chemistry, then a logarithmic scale for your vertical axis is the best way to go.